Hello and welcome. Today we are looking at normal distribution curves. In a previous video, we discussed normal distribution as symmetric, where the mean, median, and mode all have the same value. When we're looking at our normal distribution curve, the mean, median, and mode are all represented by the number in the center. And then the intervals along the x-axis tell us our standard deviation. So for this particular data set, the mean, median, and mode are all 0. And then the standard deviation is 1 because I'm counting by ones along my x-axis. As mentioned in a previous video, we said that the reason this is called a symmetric distribution is because if I split the curve along the middle where the mean, median, and mode are located, the two halves of my curve are equal. Therefore, in a normal distribution curve, I should have 50% of the data to the left of the mean, and I should have another 50% to the right. A new piece of information to this video is that in a normal distribution, there should be approximately 68% of the data within one standard deviation of the mean, which means that if I start counting from the middle and go one standard deviation to each side, this section of the curve should represent 68% of the data. So if I want to figure out what percentage of the data is between 0 and 1, then I'm going to need to section off my curve and fill in the percentages for each little piece. So I'll start by marking off the center of my curve as well as the intervals within one standard deviation of the center. Then from there, I will mark each section as 34% because I know the two sections in total are 68%, and the two halves should be equal because of the symmetry on my curve. Therefore, 34% of the data is between 0 and 1, and then another 34% of the data is between -1 and 0. The next thing that we need to know is that in a normal distribution, 95% of the data will be within 2 standard deviations of the mean. So if we want to know what percentage of the data lies between the 1 and the 2, we'll set it up the same way that we did in the previous example. So we can start by sectioning off the space within 1 standard deviation of the mean. We mark that as 68% based on the information from the previous example. From here, we'll need to figure out what percentages go in these two sections so that the total from -2 to +2 is 95%. So by subtracting 95 and 68, I get that there's 27% left over. That 27% needs to be split among these two sections. By splitting the 27 in half, we get that there should be 13.5% in each of these two sections here. Therefore, there should be 13.5% of the data between 1 and 2, and another 13.5% between -2 and -1. When we look at values within 3 standard deviations of the mean, we will have 99.7% of our data. So if we want to know what percentage of the data lies between 2 and 3, we'll follow. So by subtracting 99.7 and 95, we get that there's 4.7% left for these two sections right here. We then split that 4.7 equally between both sections. So we know that there should be about 2.35% of the data between 2 and 3, and another 2.35% between -3 and -2. So based off what we've seen so far, we should be able to answer similar questions about a set of data, even if we only have the mean and the standard deviation. So if all I know about my set is that the mean is 10 and the standard deviation is 2, then I will start by drawing my distribution curve. So when I draw my curve, the mean, once again, always goes in the middle. Because my standard deviation is 2, I'll count by 2s along my x-axis. And now we can use the diagram that we've drawn to answer the questions. So if it asks me to find the percentage of data between 8 and 12, I'll go to my graph. I'll notice that 8 and 12 are each 1 standard deviation from the mean. Therefore, 68% of my data should be between the 8 and the 12. If I want to know which section of my curve contains 95% of my data, I need to remember that 95% always lies between 2 standard deviations of the mean. So if I go back to my curve and I count 2 standard deviations to either side, my interval should start at 6 and end at 14. And then finally, to figure out what percentage of the data is greater than 14, I'll simply section off my curve like we've seen in the previous examples. So to start, I'll mark off the 14 and then highlight the sections to the right because that represents all of the numbers greater than 14. Based on the previous question, I know the middle portion of my curve between 6 and 14 represents 95% of the curve. And because my curve is symmetric, I know that whatever is greater than 14 should have the same percentage as the section that is less than 6. If we total up the 3 sections of our curve, we should get 100% because the sections in red continue past what we currently have graphed. They do not stop at the 4 and the 16. So if we take the 95 in the middle out, we're left with 5% for the other 2 sections. If we split that 5% evenly between the 2 red sections, we should get 2.5% in each. Therefore, 2.5% of our data should be greater than 14. And that's all we have for this one. I will see you guys next time.